Hello mortals. Black holes are arguably the most fascinating and mysterious objects in the universe. Insane gravity, infinite density, really cool visual design. What else would anyone want for their birthday cake? Back when Einstein published his field equations, black holes were part of the solution to the said equations. At the time they were nothing more than a mathematical curiosity. Now we know that black holes are very much real. But aside from them, the Einstein field equations also contain something very peculiar, a space oddity similar to a black hole, but very different. A white hole. If nothing can escape the former, then nothing can enter the latter. They are mathematically reverse. The two are also hypothesized to be the entrance and the exit of an Einstein-Rosen bridge, also known as a wormhole. If we were to describe a white hole in a sentence, it would be a black hole that exists backwards in time. And it gets better. One common misconception about white holes is that they push you away as you try to approach them. That is not correct. Just as a black hole, they have positive mass, and therefore attract matter towards their singularity. Then, you might ask, how come nothing can enter a white hole if it has the same gravitational pull as a black hole? To understand that, you need to first understand how a black hole distorts space-time. If a rocket stands outside a black hole, it can move in any direction it wishes, but once it crosses the event horizon, the geometry of the universe becomes so altered, that all the paths the rocket can take only lead further closer to the singularity. It's not that the rocket doesn't have enough power to turn back, it's that back also leads to the singularity. A white hole distorts the space-time in the opposite manner. Past the event horizon of a white hole, all paths lead away from the singularity. Even though your spaceship approaches the white hole more and more, it will never cross the event horizon. Just as a function that approaches zero but never gets there, so would a rocket approach the white hole but never get to its event horizon. Mathematically speaking, you would get there after an infinite time, but also after an infinite time thanks to the Penrose diagrams. A white hole becomes a black hole. That would be a bummer, to wait for an eternity in order to get to a white hole only to enter a black hole. We know that black holes are created from the collapse of massive stars. So what about their counterparts? For that you need to remember their pseudo-definition. So, you'd need to run a black hole backwards in time. But there is one issue. As time moves forwards, entropy increases. As a refresher, entropy describes how ordered a system is. A cube of ice has low entropy, but with time the entropy increases as the ice starts to melt. And by itself, the water won't form into an ice cube again. This is why, the overall entropy of the universe can only increase with time. Creating a white hole requires that entropy decreases, which as stated previously, it can't. Or, can it? Just as it is possible to roll the same dice side 100 times in a row, albeit very unlikely, so is it possible that there could be a statistical drop in local entropy. Given enough time and a non-zero probability, entropy might locally decrease, and for a very small fraction of time, a white hole could be formed. But just as quick as it appeared, it would collapse back, as entropy would start increasing again. Scientists have never yet observed anything resembling a white hole, except for one event. Back in 2006, the Neil Gehrels Swift Observatory noticed a gamma-ray burst 1.6 billion light-years away. First it was assumed to be the birth of a black hole. However, the supernova which should have happened was never observed. The hypothesis of a merge of two neutron stars was also not to be, as the gamma-ray burst had a duration of 102 seconds, compared to the usual 1 to 3 seconds. The event remains unexplained to this day, and might be the only and strongest observational proof for the existence of white holes. We also have some scientists hypothesizing that the Big Bang itself was the result of a white hole, in fact that all white holes are actually giving birth to their own universes inside. So who knows, maybe our universe is in the interior of a white hole right now, which is in turn part of a bigger parent universe, that might also be inside their own white hole, and that goes on and on. Eerily similar to the simulation hypothesis, isn't it? But what is the simulation hypothesis?